All right, guys, we are continuing with how to take integrals and basic integration or antiderivatives. In this one, we're going to learn how to find the plus c. If we're given a certain amount of information, we can find it. And we're going to learn how to do integration by a method called substitution, which is a very useful integration method. It's going to be used most times when we integrate later on. All right, so we're back to some sort of motion. So a ball is thrown upward with an initial velocity of 64 feet per second. So this is our V0 is 64. And an initial height, H0, is 80. Recall acceleration is negative 32 feet per second squared when we're working with feet, which is what we are working with. So find the position function given the height h as a function of time t. So we should know that this ahead of time is going to be h of t equals negative 16 t squared plus the initial velocity times t plus the initial height. Like, we know that this is going to be the answer. But that's just because we memorized a formula, and we don't like to memorize formulas. We want to know where do things come from. So what we do is we start with our acceleration is negative 32. And if we integrate this with respect to t, that should give us, sorry, dt here, that should give us our velocity, because the derivative of velocity is acceleration. So the integral of acceleration should give us velocity. So if we integrate just negative 32, we get negative 32t plus a constant c. That's our velocity. All right, now we can find this constant c because we're given that at time 0, the velocity is 64. So if we plug in 0 equals 64 equals negative 32 times 0 plus c. So this goes away and we get c equals 64. So we get that our velocity function is negative 32t plus 64. Now they could have given us any point. Any point we could plug in a t and set it equal to whatever the y value here is here, in which case the v value velocity, and we could solve for that c. And that's how we solve for c. So we just need any point. Next, if we want to know the position, and I guess we're using h. So h of t, the position, is the integral of the velocity, because remember velocity is the derivative of h. So if we take the integral, that brings us back to our position. So if we take the integral of the velocity function we got right here, negative 32t plus 64 dt, my t's are kind of looking bad, there we go. So this we'd add 1 here, so we'd get negative 32t squared over 2 plus 64t plus a constant. That gives us our h of t. So now we're seeing where this negative 16 comes from. Negative 32 divided by 2 is negative 16. Plus the 64t plus c. And that's how we get that our initial velocity always goes right there. And now we've got that our initial height is 80, so we got the point 0, 80. So if we plug in 0, we should get 80. So 0 there, 0 there. And this whole thing should be 80. This is going to go away. This is going to go away. We get c equals 80. And that's how our initial height ends up being 80. So now we just get exactly that. So now we can answer questions like, when does the ball hit the ground? Well, that's when h of t equals 0. So we just set the whole thing, negative 16t squared plus 64t plus 80 equal to 0. I believe everything here is divisible by negative 16. So we're left with t squared minus 4t minus 5. We can factor this into t minus 5 and t plus 1. So we get t equals 4 and t equals negative 1. So when does it hit the ground? We're going forward in time, 4 seconds. Which is basically how long a punt hangs for in football. But it doesn't start off 80 feet above the ground. All right, the substitution method. So this is where it gets a little tricky. So what we do is we say we have a function of some other function. So we set what's inside of it equal to u. And then we need this to be our derivative of whatever u is. All right, so if this is g of x, we get g prime of x, and our dx together becomes du. And then we can just take the integral of f which gives us capital F. The antiderivative of lowercase f is capital F. And we go back to whatever our u was inside after we're done. All right, seems kind of strange, and don't forget your plus c. But once we do this a couple times, you get the hang of it. So usually what's inside the parentheses or inside the square root is a good candidate to try and say, hey, maybe our u is that. All right, so now we want to take the derivative of this. So du, or sometimes we write du dx, is 2x. All right, well, here's the 2x right there. All right, so oftentimes we can just put the dx over here and we say, oh, we got 2x dx, and we're just left with du. So like we get du equals 2x times dx. So this here becomes my du. So what happens is we have the integral, we have this whole thing in here is u to the 4th, and then this 2x and this dx becomes my du. And now I've just switched to a different variable. Now I can integrate this. This becomes u to the 5th over 5 plus c. And then I go back to whatever my x's were. So my x's were x squared plus 1. So I'm going to plug in x squared plus 1 right there. So we get x squared plus 1 to the 5th over 5 plus c, like that. All right, we'll do another one here. And I think we do another one on the next slide too. So again, we've got 3x squared outside. We've got the square root of x to the 3rd plus 2. Those of you that kind of get used to doing this, you should notice that the derivative of this guy is sitting right there. All right, so we're going to try and say not just this, but the whole thing in here, because the derivative of 2 is going to go away. So we're going to include that with our u. And then we get that our du, our derivative of that, is 3x squared. And we move the dx up over here. So this is our du right here. This guy and this guy together become du. So we end up getting the integral of the square root of u, or u to the 1/2, du. So if we integrate that, we get u to the 3/2 over 3/2, or times 2/3, plus c. And now I go back to x's. So I've got 2/3 x cubed plus 2 to the 3/2 plus c. All right, so this is how the substitution method works. We substitute in a u, we can take the integral with u, and then we substitute back the x's. We just have to make sure we match the derivative of u with the derivatives of x's. All right, because we're changing our variable of integration. All right, so we've got secant squared theta and tangent of theta plus 3. I've got parentheses here. This guy has a plus 3 with him. Let's try and make that our u. Tangent of theta plus 3. So then du would be derivative of tangent, if I remember correctly, is secant squared. And that would be d theta, because we took the derivative in terms of theta. So here, secant squared and d theta, those two together, that's our du. So we get that this is the integral. This whole thing in here is u. And the other stuff is all just du. So the integral of u is u squared over 2 plus c. And then we plug back in what u was equal to, which is tangent of theta plus 3. So we say tangent of theta plus 3 squared over 2 plus c. Don't bother multiplying that out. Just leave it right there. There's our answer. All right, so sometimes it doesn't exactly work out to our derivative out in front, but we can fix that. All right? And we use that. Constants can just come outside, and it doesn't make a difference. So we can just put numbers outside, and as long as we put the same number or a canceling out number inside, it'll work. So again, we've got something inside raised to the 3rd. I'm going to say that is my u. All right, we could just cube this out and then distribute the x and then integrate it, but that's going to be a lot more work than substitution. So then our derivative du is 2x times dx. Well, we've got an x. We're missing the 2. So what we do is we say, okay, well, let's give it a 2. But now we've changed the problem. So how can we cancel out a 2? Well, we just divide by 2 or multiply by 1/2. So now this 1/2 times 2 would cancel each other out. So we're just going to leave this guy out front and we'll bring it back in at the end. And these two guys together become our du. So we get 1/2 the integral u to the 3rd du. So we get 1/2 u to the 4th over 4 plus c. So this would be, let's see, 1/2 and 1/4 would be 1/8. And we'd get x squared plus 4 to the 4th plus c, like that. All right, let's try another one. So we've got the square root. There's nothing outside except for the dx. So I'm going to say u is 4x minus 1. We don't have any integral rules for this, the square root of 4x plus 1. We have the square root of x, but not 4x minus 1. We could simplify it if it didn't have the minus 1 here. Like we could just take the square root of 4, and then we'd be left with the square root of x. But that minus 1 throws everything off. So we take our derivative. We get 4 dx. We need a 4. Well, we'll give it a 4. But we can't just give it a 4. We got to cancel out that 4, so we put a 1/4 out front to cancel it out. So now this here is my du. So we get 1/4 out in front, the integral, u to the 1/2, square root of u, so u to the 1/2, du. So we get 1/4, u to the 3/2, oops, not x, u, over 3/2, or times 2/3, plus c. The 4 and the 2 can cancel, leaves us with a 2 down there. 2 times 3 is 6, so we're getting 1/6. We can plug back in. We get 4x minus 1 to the 3/2 plus c, and there's our answer right there. So we do often end up with a fraction out in front, like this 1/8 out in front and this 1/6 out in front, but we're not doing anything with it, so it's not like these are scary fractions. They're just going to sit there. All right, so one more here. So we've got sine squared of 3x times cosine of 3x dx. Well, sine's the one squared. Maybe I can think of this as this, the integral of sine of 3x squared like that times cosine of 3x, because that's what sine squared means. It takes this whole sine thing and squares it. So this is inside the squared, so maybe that's going to be my u. All right, we don't have a rule for sine squared times cosine, so let's try and say sine of 3x is our u. So then du is derivative of sine is cosine of 3x times derivative of the inside, chain rule. Don't forget the chain rule. All right, we've got a cosine of 3x right there. We get a dx here too. We've got the dx. We're missing a 3. So we give it a 3. And we cancel out the 3 with a 1/3. So we get 1/3, the integral. This all here became u, so we get u squared. And the other stuff all became du. So we get 1/3 u cubed over 3 plus c. So that's going to be 1/9, and then u to the 3rd, and u was sine of 3x to the 3rd like that, plus c. We could write it like that, or we can change it back to how we usually write exponents on trig functions, inside like that, of 3x plus c. We don't necessarily need parentheses there. I like to put them. But there's our answer. And that's how we do the substitution method. All right, so that is the substitution method. We will probably keep using that just about every day from here on out, guys. So if that one seems confusing, you can watch it again. We'll do it in class. We'll keep practicing it, okay? See you next time.